Hello everyone, and welcome to today's webinar, Automate Your CAM Programming with the Fusion 360 Machining Extension, with your presenter, Devin Dupuy, Technical Specialist for Design and Manufacturing at Autodesk. And my name is Maria Ma, the Marketing Campaign Coordinator for Engineering.com, and I'll be your moderator today. First, a few housekeeping items to cover. Today's webinar will be recorded, then available for on-demand replay on engineering.com. For attending this full live session, you'll receive a PDH certificate within 48 hours. If you have any questions, please submit directly in your webinar interface, and we'll try to address all questions during Q&A. Now, without further ado, I'll pass it over to our presenter. Devin, over to you.
Hi, thank you. How's it going, everybody? My name is Devin Dupuy, and I am a technical specialist here at Autodesk. I've been with Autodesk for about 2 years now, and prior to coming to Autodesk, I ran an aerospace CNC machine shop. Some of my experience, I have been in manufacturing for over 10 years now, and I do specialize in advanced manufacturing techniques, and I've been a 5-axis CNC machinist for quite some time. Like I said, prior to coming to Autodesk, I did run an aerospace machine shop. So this is some of the stuff that I used to do with Fusion 360 on a day-to-day basis. So all of our model preparation, fixture design, and then even programming some of these complex machines you see in front of you, we're all done inside of Fusion 360. Some of the things we want to focus on today and the topics we'll be covering are, we're going to go over the manufacturing extension. And the first thing in that extension is probing. And we're going to talk a little bit about probing and how we can automate some of your processes and go ahead and keep an eye on some of those machining tolerances for some of those trickier parts and things like that, and how this could speed up your workflow. We'll also look at hole recognition, and this is kind of an automated finishing strategy for identifying multiple holes on components, whether they're at normal to the z-axis or at multiple angles on a multi-axis machine. We're also going to look at toolpath editing and how this could increase your efficiency by trimming out little unnecessary areas and little tricks to get the toolpath exactly the way you want it in a very timely manner. We're also going to go over the rotary toolpath, which is a continuous 4-axis strategy for simultaneous 4-axis finishing. Then we will touch on some of the 5-axis options that are available in the extension. And we will lastly talk about the steep and shallow toolpath. So with all that being said, let's hop over to Fusion and let's take a look at some of these items. All right. So the first thing I want to go over in Fusion, and I do want to let everybody know that I do want to keep this very technical, but I also want to keep this high level. So no matter what your experiences with CAM and manufacturing, hopefully it will be good for all audiences. So the first thing we're going to take a look at that can increase your workflow and some of the beneficiency is probing. Now, when we talk about probing in Fusion, what this is on a lot of machine tools today, we have probes, which are essentially measuring devices that are in the machine that we can use to inspect the part, find the origin, or help us even set up a part by finding certain locations on there. One of the things you see here is if we do have some tight features, and I'm going to open up this toolpath and just take a look at this. If we have some tight features here that we're trying to make sure are within tolerance, we can set those things up in our toolpath here by setting up our positional tolerance. And then what we can do is actually in the action size here, there's a bunch of different actions we can take if something happens to be incorrect. We can have this alarm if this feature was machined out of position, and the machine will then stop so we can realize that there is a warning in our process and there's something we need to fix. We can also have this stop if there is a wrong size. So if it measures the item outside the certain tolerance, we can have this go back and obviously let us know that there's an issue there. The next thing, and I think the most important, is that we can choose what operation is actually machining or creating this feature, and we can have the machine update the toolware. So if this was a component made out of steel and you're using like a carbide end mill, over time, that carbide end mill is going to wear out, but that doesn't mean that it's bad. We would want to adjust the wear offset on the machine to keep our components within the range of the print. And Fusion can actually measure this and then take that information into control and adjust your tool wear offset for you. So this can be very, very beneficial there. The last thing is maybe I'm making 20 of these components and I do want to inspect every one of these. We can also turn on this print results. And what this is going to do is it can also tell us to increment the component, which is a feature that I like. This is going to actually record in your machine every measurement, when it was taken, and what that measurement was. So that way we have a record and we could see maybe we're making thousands of components, or maybe we're making 10 that are very, very tight tolerance. And we want to have some sort of record of that, at least on the machine, before we bring it to quality control. This toolpath can also do that. So with all this being said, this could be obviously very, very beneficial for keeping track of certain toolpaths and certain geometric features that we might want to pay extreme attention to. The next thing is, what if my part is a little bit more, I would say, non-prismatic? So if we go into something like this, we obviously have kind of this free-form, lofty surface here. This could be for a mold, a die, a punch, something like that. But when the customer sends me a part, I want to make sure I'm maintaining their surface integrity. So what I might do is, once I've machined this component, I might make an inspection toolpath here, and these are very easily made. So we can really focus on the areas that we're going to look at. So if I say inspect surface here, you can see Fusion brings up my probe, and then I can really pay attention to the areas that I want to inspect and take some point measurements on. And we can do multiples of these. We can also do obviously all over the part. Maybe I want to make a check here and a check on this surface and over here. So we can make a very custom program based on our surface and the items that we want to check. Now, what's going to happen is, once we run this program, Fusion is going to, in your machine, is going to record all those measurements, and they can be imported back into the machine and back into Fusion. And what you will see here is we can right click on this toolpath here and say show results. And we can see that the inspection results have been recorded. So not only all of our nominal dimensions, but where it was actually contacted, any offset that we may have adjusted, and then that actual delta and deviation are here, and I can see those errors. Now, one other thing that I think is very beneficial, especially for inspecting these features, I have this on the pin mode, and you can see that some of these green dots have different heights on them. Now, these heights are represented by how off they are from the actual measurement. So some of these, although they are green and they are within tolerance, some are smaller and some are taller. That just indicates how far away from the mean of that tolerance we are. These ones here that are indicated in blue obviously are outside of our tolerance, and they have more material, so they are represented by that different color. I do not have any that are under tolerance, so on this specific component, I could leave it in the machine, and I can go remachine these areas where I see there's an issue. Now, one other thing, and another thing that's very common, is what I might do instead of doing that on the machine, if I don't, if I didn't have that probing, or I want to manually check this on something a little bit more dedicated to measurement, like a CMM, I might take this component off of my machine. And what I might do is bring it into that room, have it acclimate to the temperature, take some measurements on it. And then if I do find that there is some sort of issue where it can be repaired or fixed, I would have to then take that component and bring it back over to the CNC machine. Now, that can be very troublesome, especially for something like this, because even though these are some straight faces here, these might all be at different angles, and this might not be the easiest part to get in and out of the machine back in its exact position where it was. So what we can actually also do is take an inspection like this, so we can place the component in the machine, and we can utilize the part alignment feature. And what this does is take that information from the inspection results, choose what kind of machine we have, because even if we have a 5-axis machine, we can alter the position of the part or how it's actually sitting in the machine and generate a program so that we don't have to spend a tremendous amount of time setting these back up. So that can save a ton of time there. And that's something that I've done, in the past quite a bit. So let's move on to the next thing. So the next thing that I want to discuss in the manufacturing extension here is hole recognition. And this is one of my favorite strategies for increasing my productivity. You can see even on a component like this, there are a lot of holes, and they are also holes at other orientations. So there's a few different ways to look at this, and this is really just meant to be a simple click. So if I go up here and I hit hole recognition, this will analyze the part and it will look at all the features on the hole. And I'm going to open up one that I have here so we can see some of the options. This first one here, and I'll make this big, because we've already generated this, you can see it says keep existing, but if I did identify this 1/4-inch hole needed to be something else, I could certainly modify that to be a drill, tap, and a bore there. So we can look at the specific holes. Also, when I am clicking on this, I know it's a little hard with this box big, so I'll try to move it out of the way here. You can see when I'm identifying these holes, it's showing them to me. Now, what if I was looking at this component going, oh, I'm just going to make this in a vertical 3-axis machine? I actually don't have access to drill these holes in this operation. Well, by default, Fusion says limit to setup plane, and I have this unchecked. But if we wanted to turn this off, then it would only look at holes that are vertical to our z-axis, and it would ignore any of the holes at any of the other orientations. You can see this being very beneficial for setting up 3-axis machines, but also we have a multi-axis machine, and we're going to plant this component on the table. This will obviously write all the holes and processes for all the holes at any orientation. So if we had a very complex part with even more angles or directions here, Fusion would go through, identify those holes, and try to properly apply a strategy there. The last thing that I think can be really important is what tool library is it using? So by default, we are using the sample library, but if you had a local machine in here, we could say we want to look at a local machine, and maybe I want to do this in my UMC 500. Now it is only going to look at tools that I have associated in this library. So it won't make any unnecessary tools that that machine doesn't have, and anything that it doesn't have, it will just omit if a tool is not in the machine. So this can be very beneficial for programming and automating holes. This other one that I have here, you can see is set up just for our z-axis normal. So from our machining vector here, you can see that it's only grabbing holes from this orientation, where the other one is grabbing holes from all orientations because it is set up for a 5-axis machine. So this can save a ton of time with automation. And whether you even have a part with a few simple holes, even when we're doing one hole that's a spot drill, a tap, and then maybe there's a chamfer or counterbore or something on that, this can be a very valid strategy because it not only, even for that one single hole, it'll make all 4 of those operations for the single hole. And obviously, if we have multiple holes, you can see we're making 4 operations for each size hole. Can be very time consuming, and this really automates that process and kind of takes it into the computer's hands here. So I hope that makes a lot of sense. Let's move on to the next one here. So the next thing I have is really something that I've struggled with a lot in the past. And sometimes what happens is we'll make a toolpath, and let me just expand this real quick. If we look at this toolpath, from a high level, it looks pretty good. But when I start zooming in on it, I see some areas in here that I'm actually not a fan of. So I see it diving down into this hole where the tool actually fits, which obviously doesn't please me very much. And then I also see over here, there's I call this like a waterfall, but the tool is essentially waterfalling or spilling over the side of the area that I have selected. And this could be caused in many different ways. Obviously, how the model was designed, how we selected our toolpath, and sometimes this can be very, very tricky to go through and fix. So let's do this. Let's go to the 2 holes here. And from the top, I can see kind of these messy areas. And we have 2 different modes to do this. One of them is kind of a really manual one, but if I say I want to trim out, and I'm just going to make a kind of a simple polygon here, and I'm going to take some of these segments with me. I'll just make kind of a selection there. So I like that. I'm going to hit accept. And what I'm going to tell it to do is keep the outside of the boundary. So with a very short click here, we can easily trim out that toolpath to get rid of those sections that I don't want. Now that is the first way to do it, and this is a really custom way to do it, especially if you see something you don't like or if it's halfway on a toolpath segment. The other way is called delete passes, and delete passes works similar but a little bit different. It allows us to do things like a window selection here, and anything that I have encompassed in that window, you can see the selection was obviously different than that polygon, but it automatically grabs all those areas, and I can tell it to do the same thing, just trim them off. and it will reproduce a tool. It will actually trim off that toolpath and give me my result. Now, this is great, but what if I went in and modified this toolpath? What if I went in and said, hey, I want to change this? Now, a lot of users are accustomed to this type of feature. What they're not accustomed to is when I go in here and I make this something like 0.1, because maybe I want to do like a semi-finish on here. When I recreate this toolpath, generally all my edits are lost. And what this does is it actually keeps the edits that I made based on the tool size, even if I change my toolpath. So no matter if I change my cut direction or my step over size or even my tool, my edits are maintained. And what we can see here is when I grab this, we can see that down in the timeline here, I have some of those features. So this one here looks like there's an error because maybe I selected some passes that are no longer there. We could right click on this and we could easily say delete. And if we didn't like the other edit and we wanted to see the original, we could also click the original edit and hit delete. And then it will produce the toolpath how it was originally without those edits. So these edits maintain associativity and we have a history of them. One other thing that is new is I'm gonna randomly make another one of these here. We'll just say that we'll trim off an area like that. I'm gonna put a note in here, trim for G. And when I put in that note, this will let anybody else looking at the toolpath, when they see the edit and maybe why it was done, they can hover over this option and you can see there's a note there and it says trim for manufacturing, or for MFG for short. So it does allow other operators to see maybe why something was trimmed off and whatnot. So let's go back in here. We'll delete this. And then I'm going to double click this and let's go back and make this toolpath fine so we can look at those other areas. One other thing to note here is obviously this toolpath is generating right now, but you can see my Fusion's not locked up and I can still create new toolpaths if I wanted to. So Fusion is hyper-threaded while all this is happening. So even though that toolpath is generating in the background, we're still able to continue working. And that's a pretty complex and a pretty dense toolpath that we just created there in just a few seconds. You can see how tight some of these lines are. And if we look at these other lines here, you can see I have also some views set up to look at these particularly tricky areas. And I can do the same thing. I can come in here and make a trim toolpath, or I could even say delete passes. And I can zoom in on this problem area here. You can see how nicely that's selected, just the segments that are fully encompassed by my selection, and hit OK, and easily just get rid of that entire bad section. So toolpath editing and trimming can be done on finishing strategies. This is limited today to finishing strategies only. So like roughing strategies, if we did allow the customer to do that, it would obviously be pretty, it would be not intended for a user to, eliminate the top part of their roughing strategy and have their tool crash into the stock. So we are trying to keep it safe there, and that's why the other strategies aren't allowed. But on these finishing strategies, these are mainly the ones that I have, issues with. It makes going back and trying to make other selections and boundaries very quick because I don't even have to go back into design and try to make a boundary or trim something off. So this can be very beneficial with saving time there programming and getting exactly what we want in a short amount of time. So let's move on to the next thing. So the next toolpath that I want to talk about that is available in the extension is the rotary toolpath. Now, this is a particularly favorite strategy of mine. And if we click this toolpath and look at some of the options right here on the passes, we can see what this toolpath does. Now, this is a cyclic or a continuous 4-axis finishing strategy. And you can see there's some different modes there. And with these modes, we can play with them even more by selecting surfaces that we want to touch and things like that. And I'll show a little bit of that. But the main one, spiral, is the one that I use the most. That is my favorite. It does just spin the part and allow me to walk into the material and choose the step over that I want. So it is going to continuously spin that 4th axis so I could machine a part like this, because this would be a particularly tricky component to do multiple orientations on, and especially if it wasn't symmetrical. If it wasn't symmetrical, it would be even more difficult because I would have to make a tool orientation or something for each individual vector or position that I want to machine from. So let's take a look at some of these and how they work. So if we right click on this and we hit simulate, there's also a new thing in Fusion, and I'm going to turn off the show axes, and we can turn this to tail. We'll even turn the stock off just to simulate a little bit quicker. So one of the things that I've always kind of been a little irritated with is when I play this toolpath, you'll see that the tool is going to go around the part. Now, generally for something like this too, this isn't something that I'm a big fan of. And I mean, I can guess and I guess simulate what this would look like, but I kind of want to see the part revolve while I'm doing this. So there is actually a brand new option in Fusion to let us do this. So if we go down here and hit Tool, now what this will do is actually lock the tool, and it is going to spin the work so that I can more accurately get a representation of what I'm machining. And obviously if I have the stock on here, you might have to bear with me while this loads. When I have the stock on, this can be really beneficial once it catches up to show me what I'm actually doing. So now I have a really good representation of how my part is being cut, what kind of stock is being removed, and I don't have to sit here and get dizzy trying to follow the tool around. So this is a really cool option with this. So this is obviously revolving entirely around the part. And this may be what I want, but maybe I have a little bit more tricky part where I want to just stick to a certain section. You can see here that I have a rotary, and if we double click on this toolpath, let's look at the geometry section, and you can see there's some angular limits that are set here, and they're a little bit hard to see, but you can see this blue windowed area there. These are the areas we're going to, and I've picked some points here just to determine where I want those to start and end at. Maybe we'll try to get a different view, and you can see that this toolpath, instead of continuously revolving, is now just going in that area that I have selected. So this is one way to, I guess, constrain the toolpath from doing everything. There is some other ways in here too, or you could just leave it be 360, and then we could go to avoid touch surfaces, and we could just touch whatever surfaces we actually wanted to affect, and then it would apply that strategy to the affected surfaces. So if we had more than one orientation that we wanted to do, and an angular limit just wouldn't cut it. There's also some other modes in here to get at that. So this is a pretty good example here, and let's just we'll take a look at this real quick just to show what this is doing, because this is utilizing one of the other strategies in here, and this is the line strategy. So this is going to do angular movements and go in and out of the part. So this can be beneficial too, even on like 5-axis machines. Sometimes like a head machine won't have continuous rotation. So this is a good way to pick a starting point and have it revolve around within the machine limits. And then obviously if this was required for the surface we were doing, this is obviously another way to do that. So let's go into another part here. And this is another one that we could, utilize that strategy on. So let's actually make a toolpath. I'm going to go in here and go to rotary, and let's select my tool. I have a lot of documents open, so we'll just grab one of these, and we'll place that end mill in there. So this is set up on I believe a 5-axis, but what we want to do here is we'll have some selections to do. So I want to pick my rotary axis, and I can say set up x-axis. So that's going to give us that. And if I just hit OK, let's just see what this does. And generally, I would say when we're making toolpaths, that's my preferred method, especially when I'm learning a system. Don't make a ton of edits. What I want to do is just pick my tool, and I want to get something to generate. I don't know how many times that's happened to me where I went in, I changed 17 different settings, and then I hit generate, and then nothing happened. I was just left very confused. So before we go in and change a ton of stuff, let's just kind of see what it does. And then I get a really good idea of what I need to change. So I obviously don't want it to do these outside bores. I really want to stay in this center. And I also want these to be a little bit tighter. So what we could do here is edit the toolpath. You can also double click the tool icon to get this to go into this edit mode. But let's go to geometry, and I'm going to just look normal to the side. And I can see there's a front and a back, and they're actually indicated by these little hands here, or by these little lines. And I can take this little hand, actually move them to where I need to be. So I can zoom in right on the radius of where I want to start and place these. And that looks good. And then I also want to affect the spiral, how it was going across. So we can go in here and we can go to step over, and let's just make this something tight, like 10 thousandths. And we'll hit OK. And the direction is set to both ways, which is fine. And while that generates, should be done pretty soon here. And there we go. So that looks pretty good. Really what I kind of wanted here. And I've talked to a lot of customers, trying to do things like this. And this is actually, a really easy way to produce a strategy like this. In a lot of other systems, this is a very difficult thing to produce. And we really try to make it very easy inside of Fusion here. So we can right click on here and hit simulate, turn the stock off. And we can, again, my favorite part is play the spinning how it would in the machine. So we can see this, going down that radius and going into here. And then obviously it's going to be lifting up when it goes over these fins. And depending how we rough this out or finish this, we can do, this selection, or we could even do another one of these by right clicking on this. And one of my favorite things to do is actually to duplicate the toolpath. And then we can take this duplicated toolpath and we can alter the strategy to like line. And then we can choose what our step over is. Maybe we'll make it 2 degrees. We can hit OK. And we can immediately see a different strategy, right? And then I still have my original here to reference. One of the other things that I like to do, especially when I'm looking at toolpaths, is I'll turn this little eyeball on. And what this allows me to do is view the toolpath that I have selected, and then I can hover over the other toolpath and I can see some of the differences there. So you can see they're overlaid over each other right now. And if I click this toolpath, you can see in the dark blue is the one that I just generated. We can turn the eyeball off. So this is a good way to compare and contrast two toolpaths and what they're doing. So we can see we have kind of a linear strategy here going across, and this might be required for getting some of these tighter areas in there. So that's about it for rotary. And we can also use the toolpath trimming on this rotary toolpath. So maybe we, want to omit certain areas or certain fins, or maybe one of these is, missing. We can certainly do that with those edit functions that I showed earlier. Let's move to tilt and turn, which is some of my favorite stuff. So this is getting into some of the 5-axis, right? And generally with 5-axis or even systems in general, when we're looking at doing planes or machining operations in a 5-axis and a 3+2 machine, we want to make different planes or frames or different vectors. And in a lot of systems, that work is required to generate a toolpath. In Fusion, it's not. So I've already created a roughing operation here, so we can just focus on the finishing. But even for those new to this, maybe this would have been beneficial. I'll delete that. Sometimes I make mistakes. And I'm going to say create from template. And I have a arrow roughing toolpath. And this is actually just a strategy with the tool that I have here. And you can see that it's obviously not doing anything. So I can paste in a template there, and I can just hit generate. And I can easily get the roughing done on this part, so I can focus on the finishing. So that's another great benefit of Fusion 2, especially when you make one of these toolpaths that you actually like. It's really good to right click on the operation, go down, you can say store as template, and then you can save that, name it for later, and call it up in the future. So let's look at some of these faces, and let's start over here. So maybe I want to make a parallel toolpath on this radius portion. Sometimes we could do this from the top, but maybe I want to obviously have my tool leaned at a certain angle. And what we can do here is just go into 3D, and we'll do this as a scallop actually. We'll come in here and pick a different tool. Grab this little guy. And a lot of times what happens is the only options I have are my z-axis normal, my machining operation where it's at 0. And if I wanted to tilt this, like I said, in other systems I'd have to make a frame here. Let me show you how this works inside of Fusion. With the extension turned on, we have this tool orientation option. And in here, we actually have some further controls. So you can see that I can just grab this x-axis and just move it. And then I can spin this orientation down. And now my tool is going to face that direction. Now, that's a really good way to do that. And let's make an operation here. So I'm going to say selection. I'm going to grab this area here. And we'll go to my passes. We'll say 0.02, and then I won't have any boundary overlap. I'll put that at 0, and we can say contact point boundary. This is another favorite tip of mine. Contact point boundary I pretty much always use, and this is a little trick to let the tool kind of violate the boundary to finish its contact. So on this little window here, you can see in that upper left-hand corner where it says disabled, That red line that's going up and down is the edge of our assumed boundary. And you can see that that purple or blue kind of diagonal line there is where the tool is contacting. So if we made a toolpath like this, we would actually have a scallop at the bottom there. Then we would need some sort of hand finishing or another operation to complete this. And with the setting turned on, it'll actually allow the tool to violate or go outside that boundary to finish the contact there. And it still won't violate your model, obviously. If there was something below there, we would have to either use a different tool or whatever, but this is always going to make my toolpath not miss any of those areas in my selection. And then inversely, actually at the top, in the bottom of the display window there, for the top of the toolpath, it won't roll the tool unnecessarily up and over the top. So it'll actually stop it at the contact so that we don't get that wasted motion. So I'm going to turn that on, and let's just hit OK. We can see my tool is going at that orientation and it is machining those areas. Now, maybe I run this on the machine and I like this, and oh, look at that. That's a problem there. So what we could also do here is maybe I could go in and change my direction or things like that. But what I'm going to do, just use that little trick from before. Let's go in here, zoom out. And I'm just going to go to toolpath trim, and we'll take an area like that. We'll say we want to keep the outside boundary, and we'll hit OK. Now it's going to generate that toolpath without that unnecessary stuff that we didn't want. And then, so that looks really good there. But what I might want to do is change the orientation. Maybe I run this and I realize, hey, my tool's a little worn out in that spot. I want to adjust what orientation I'm at. We can double click on this icon, go back in here, and let's look at some of the other tricks that are in here. So one of my other favorite ones, and sometimes you have to be machining ninja to get this right, and I am, so it works for me, but it doesn't work for everybody. Sometimes what we need to do is actually align to a view. So like you can see I'm moving my view around, and I'm going to put it, let's say right here. There's a little button here that says align to view, and it's actually going to parametrically align this to the view that I have right now and then save it to the toolpath. So that orientation there is now saved, and my toolpath is now coming from that orientation. So we can easily modify this without having to go in and make additional frames or make additional planes or work coordinates or whatever it's called in some of those other systems. Makes it very easy to go in there and adjust what my tool axis is. And the last one here that I think can be really beneficial, and I'll show because this is a little kind of a hidden gem in there. We actually go in here and we go to surface normal and x-axis or y-axis. We can choose the direction. You can see this little pointer that I have on my screen here. Wherever I put this, it's actually going to put the tool at that orientation. So I can manually just kind of jog on the surface here and choose what direction vector I want to have. Maybe let's say that one. And it puts the orientation right there. So it gives me that really fine tunable control when I'm looking at a surface or looking at something to adjust what this origin is. And this is really a big help. I used to have some pretty crazy tricks to go in and make a component and then make a ball joint and move it and set my tool to that. So this really eliminates any of that hard work that I used to do all the time. So from there, let's go into steep and shallow. Now, steep and shallow is kind of the next thing, and really it's what I want to focus the majority of my time on, because there's a ton of stuff here. Steep and shallow, if you really break it down and look at it, it's actually 5 different toolpaths. It is a ramp toolpath, it is a contour toolpath. So like right here, let's say it's ramp, it's contour, it's parallel, which is here, and it's scallop, and it's steep and shallow, which is a combination of any 2 of those things for steep and shallow areas. One of the reasons why steep and shallow is so beneficial is because not all toolpaths are created equally. So let's look at this. And I'm going to go in here to make a parallel operation, and I got to change my tool because that face mill wouldn't do me any good. I'm going to go to the top here, and again, I just picked my tool. Let's just hit OK. The reason I put the view to the top is so we can see what it's doing. This toolpath is what I would call a projected toolpath. So essentially what it's doing is looking from the tool down from the tool, and it's just striping or projecting from this view here. And that looks good, right? If I go to this side, it looks pretty good. I mean, it's going across. It's probably not as dense as I would like it to be. But there's some inherent issues with this. In areas opposite the cut direction, obviously front to back here is our cut direction, the toolpath can fall apart. So do you see if we look at it this way, we see some spaces that are way wider. And if we alter this toolpath to go 90 degrees, this will be even more apparent. By looking at the sides. Now I know you're thinking, Devin, well, why does it do that? And I thought that same thing for a long time. But if we look at the top view, it's just like a CNC machine. It is literally just doing what we told it to do. And from this view, it's making a parallel operation, striping across from the tool. And again, areas opposite the cut direction. Now the cut direction here is left to right. We can see that we have these big gaps in our toolpath. So how do we fix something like this? We'd have to make a different toolpath, essentially. So you'd have to go into 3D, and we'd have to go in here to contour. And contour is a toolpath that's generated a different way. So if I go in here and we say, I'll make this 1/8 of an inch, 0.125, we hit OK. This toolpath has its own issues. So it's not projecting from the top. We can see that from the top here, it looks a little bit different. So the algorithm must be something else. If we look at this from the front, though, this kind of operates like a 3D printer, right? Just slicing the model, and wherever the tool would make contact with the model, it is placing a toolpath there. So commonly this is called a contour, but some systems call this waterline, and it's almost like having the part in a container and then filling it up with water. Wherever that line happens to be, that's where the tool would touch it. So that's really how this is generated. Now, the problem with a toolpath like this is that we can't do anything flat with it. Anything like this surface, we could never produce a toolpath on this area with that strategy. So this is where that problem comes in, and where steep and shallow starts to solve that is we're looking at, okay, what does this toolpath do the best, and what does this toolpath do the best? Let's combine them. So let's go up here and make a steep and shallow strategy. Now I'm gonna set these passes to be a little wide, so we'll set these as 30 and put this one as 30. And I'm just gonna hit OK. Now, again, like I said, that's my favorite method for generating 3D toolpaths because I don't have to change 100 different things and then figure out why it didn't work. So that looks pretty good. Now we can see that this is doing kind of the best of both worlds. It is striping and getting me a good toolpath here. I'm not a big fan of some of these breakdowns with scallop and the way that steps over, but this is at least covering the entire part. And if we look at this a little bit closer, we can start to identify the different strategies here. So this is a contour toolpath here, and then this here is a scallop toolpath. So this is using that scallop strategy. And this is where I said steep and shallow is a bunch of different operations. It's really kind of whatever you want it to be. And I don't like this scallop, to be honest. So what I'm going to do is actually go into this toolpath. I'm going to go to passes, and I'm going to change that scallop toolpath. I'm going to make it a parallel toolpath. And now let's just hit OK and see what this does differently. So this is where I'm talking about we really get to pick and choose the best of both worlds and make the toolpath the way that we want it, and get the specific strategy, because I didn't like how that was collapsing and going around there. And obviously there's a bunch of leads and links in here, and we can change and modify those. But let's go down to the bottom here. Let's just turn those off so we can look at it. Now we can see that we're getting that parallel toolpath across the part here. We're getting that contour toolpath in the other area, and I get to choose what the blend distance is here. You can see some of these toolpaths overlap. Now, the reason they overlap is because I told them to, and generally this is what you want. So a common thing that we used to see a lot, and I've done hundreds and hundreds of times, is with this parallel toolpath, what I would do is go in here and make a slope containment. And we could say slope, and we could say from 0 to 45 degrees, because parallel is really good at those areas. We can see this kind of trims it out to be that way. We can then go into contour. We could do the opposite here. And we could say this one also wants to have a slope containment. We could say from 45 to 90, or if I went from 46 or for 44, so I had like a degree of overlap in there. This is where we could get a problem on feature-rich parts doing this, because we might have some that blend and we might have some bigger angles there, because 1 degree might be a certain degree on a part, and it might have both toolpaths doing that entire surface, which could be not very beneficial. So You can see if we shift select both of these toolpaths, this kind of does the same thing, but I'm missing the overlap. I'm missing the ability to create different strategies. And also the bottom here, this flat area, I don't want that. So if we go into steep and shallow, we could even go to geometry here and it says flat areas. We could just say avoid flat areas because generally any flat area on the part here, I'm just going to machine with a flat end mill. So when I hit OK on this, we can see that this gives me all of those benefits of getting the different surfaces, getting the, the tool path that is proper for that surface, and give me the right finish that I want in not a lot of time. Because steep and shallow is one operation. You don't have to make multiple operations to do multiple things. I can get the best area of this mold cavity here, or this mold, and get the result that I want in a quick amount of time. Because generally, even when we're doing these strategies, we'd be going back and forth and we'd be creating different strategies. And on a larger feature-rich part, I might be segmenting out certain surfaces to do. I might do this surface and this surface with one toolpath. I might do these surfaces with another toolpath. And that takes a lot of time. Steep and shallow really connects all of those things and gives me the best result. So the last thing that I really want to focus on, and is really kind of my passion, is some of the other controls that are in steep and shallow. And steep and shallow, again, is from the extension. And I guess to explain that a little bit more, this is actually taken from our Power Mill product. So Power Mill is a really dedicated 5-axis solution for, doing molds and things like this and controlling advanced 5-axis machines. But instead of going out and having our customers purchase Power Mill, if you want some of these features inside of Fusion, they're available via this extension that I've been showing you this entire time. And it gives you access to that same brain or engine that makes toolpaths inside a Power Mill at a fraction of the cost. So what else comes with Power Mill that I'm really passionate about is all the 5-axis controls. So I don't know if you guys noticed, there is another page in Steep and Shallow. It's called multi-axis. And the simplest thing I could want to do with 5-axis is just taking a regular one of those strategies, parallel, contour, scallop, ramp, and turning them into 5-axis, right? That's probably what we want to do the most. And generally when we're doing something like that, we want it to be automatic. So we could just turn on collision avoidance here, and this is going to automatically convert a 3-axis toolpath into a 5-axis toolpath. So if I want to use a shorter holder or a shorter tool, I can really get the benefits out of my machine tool while maintaining rigidity and increasing my surface finish and my productivity. Because I mean, we've all probably ran tools that were hanging out 4 or 5 inches and they probably didn't sound super great. So we had to slow it down, slow down the RPM, slow down the feed rate. This lets me put a short tool in there that's stubby, that's rigid, that allows me to cut fast and efficient and get those results done. Really the easiest way, just a simple checkbox. So let's look at an example for that. So I'm gonna go in here, go to 5-axis parallel. Now this is a lift fitting. This is something I actually produced for an aircraft in the past. This is what opens up like a hydraulic door, and this goes in the door of the aircraft. So this is a pretty extensive part to machine, and it did take a ton of time for me to program this. I'm gonna be honest with you. It was extremely tricky for me to get this area. And really, if we start looking at a part like this, why would this be hard? I mean, it doesn't look very hard. Well, the bottom of the floor here is curved. That looks pretty simple, but let's do an analysis. And one of my favorite tools inside of here are different than like draft analysis, and certainly we don't have access to that here, but it's called accessibility analysis. And this kind of does like draft analysis, but a little bit differently. So we're really looking at specific machining vectors that we're going to process our part with, and we're going to display areas in red that would not be accessible by that tool. So if I invoke this accessibility analysis here, see I can select my body, and then I need to select a direction. Now there's really nothing straight in the direction I need to machine on here, so I'll have to open up my model. We'll turn that on and we'll grab the bottom here. So now we can see that there's some red areas on there. And the reason these red areas are highlighted is because they are undercut or occluded from my Z-axis normal. And what that means is if I just go to my top view here, I have this set to orthographic, and we can see that nothing here is displayed in red. But if I highlight one of these surfaces or touch one of these surfaces, you can see that the undercut here is pretty extreme, and it's in more than one location. So all these pockets here are normal to the floor of the surface here. then even these front cavities, which this was a really big pain in the butt for me to make this the first time. So let's look at how we could fix this. So a regular 5-axis strategy here, and let's just open this up. We can simulate it. A regular 5-axis strategy, it might take some time, and let me change this back to model because that's how I want to see it. But what this does is, hitting that checkbox is going to give me an automatic solution. But here's where that solution falls apart. When I go in here, like even this first motion here, like obviously it's not colliding, it's standing the tool up, the tool is free and clear of the part. When I get over here to where this wall is, it's going to jerk the tool out of the way. Now that jerk motion there is not very desirable. It's not going to look good on the machine. It's probably going to scare us the first times that happens when the part just automatically tips out of the way. And it's not going to produce a good surface finish, to be honest. So what we would want to do is there's a specific setting in here. We'd look at this one that I have here. All I've done on the multi-axis page, I have automatic selected, which is what I've been showing. There's a smoothing angle, which this is how the toolpath is smoothed over a certain angle. And then there's also a smoothing distance. So the only difference between the first toolpath I showed and this toolpath that I'm now going to simulate is I've increased the smoothing distance to a larger distance. Before it was set to 200 thousandths, and what that does is when that tool was stood up and it was traveling down that path, when it saw a collision, it said I have 200 thousandths of room to fix this. So that's why that jerk motion happens in such a short amount of time, because it has to correct it in that amount of time. So me giving it a bigger distance here, 20 inches, so let's see how that looks. We can hit simulate, and we can see that this is going to play across here, and we don't see that jerk motion, and we actually don't see it correcting and standing up the tool because it can smooth it out over the 20 inches here. And what this is doing is actually really nice. It's staying fixed a lot. You can see at the end I'm getting some multi-axis articulation. I can actually turn on the axes, which can be beneficial here to showing that. And when we play this, give me 1 second here, my computer's having a fit. Simulate. When we play this, we can see that the motion here that I'm getting is much smoother, and I don't have those jerk motions like I did before. The other thing is, obviously we love 5-axis, right? I love putting 5-axis stuff on Instagram, things like that. But with the caveat of if you don't have to do it, let's not do it. When we do introduce all 5 of our rotaries moving at one time, what happens is we get volumetric error, and really we're limited by our slowest axis on the machine, which is most likely one of our rotaries. So if we are doing, a toolpath 5-axis here, and we have to do this to correct the motion, what I would like to see is kind of what this toolpath does in the middle here. And if we look at this, I'm going to go to the side, and I'll hit Control-7 to do a wireframe. We can see that once it reaches the middle there, where we don't have any collisions on either side, it actually finds a tool orientation where we could machine this from, and it locks 3+2. Which is my desired result, because I don't want it to be 5-axis the whole time if it doesn't need to, and it's obviously going to run faster this way if I can do the 60% of the toolpath in the middle from a fixed location. So this is where that making just a vertical toolpath into 5-axis becomes really beneficial, because this is what it's doing, and it's correcting the origin even from our z-axis to get a valid solution. So we don't have to do anything, just check a box, and this makes it for us. And then you can see obviously here, if I go to the other side, it's going to tip out of the way and give me a good result there. So that's one way to do it. And that mode, if we go in here and make it steep and shallow, the mode of collision avoidance is automatic, and that's how we have this. Now let's back up a second. I'm going to uncheck this, and let's look at primary mode. What primary mode does is this is the mode for the entire toolpath. So vertical would obviously make a vertical toolpath, which hopefully all of us know how to do. But it also lets us take into account how we want to make a 5-axis toolpath. Now, lead and lean is based off of your surface normal. When we turn this on, it is going to make a 5-axis path. We can choose the lead or the lag, or the lean, which is the side of the tool, and then again how that's smoothed over the part. So we can look at the surface normal of something and really tell it the direction we want it to face. And then we could also have it have collision avoidance. So maybe we choose it to do this and it's still going to crash in there on the sides because that tool is kind of long, but it'll still hit. We can also turn on collision avoidance and also have a solution for that. So some of these in here are automatic, but this lets us choose, for one, the entire tool axis, and then this lets us choose when it's colliding, what is happening. So there's a ton of control here to get exactly what we want, and this is something that I've struggled with tremendously in the past, and this is a great help to me. The last thing here is when we do reach one of those machine limits, what are we going to do? So down here where it says tool axis limits, there's some options here. Now, limit type can be maximum tilt. We can also limit it to 4-axis. So we can even use steep and shallow on some 4-axis parts to do a different type of strategy. And then when we do reach that limit, let's say I want this to be 45 degrees. And if we hover over this option, it should show us what that means. So 45 degrees is something like that. I'm saying from the z-axis normal, I want kind of a cone to go 45 degrees and no more. So once we reach that limit, what are we going to do? Areas beyond the limit here, and this is something, again, like I said, is really powerful. With the maximum tilt being at 90 degrees, you can see that dome shape there. It's covering the entire thing. When it's limited to like 65 degrees, you can see it only reaches a certain area. And then if I say we're going to, trim the toolpath at that would be the result. But if I say lock at, maximum tilt, machine at maximum tilt, it is going to lock at 65 degrees and then continue machining down. So it really gives us a ton of different options there. And let me show you another result here that could be beneficial. So this is me controlling the tool axis. So this is like a fan. This could be a really hard part to machine. You can see this face here. It's undercut. Obviously, there's some long reaches here and everything like that. All I've done was take a very simple point, and this is the simplest way to do this. And I told Fusion to stay connected to that point at all times. So when I play this, once a tool comes in, you'll see that this tool is going to stay connected to that point that I told it to stay to. So I'm choosing the motion. I'm choosing where the tool is going from. And we probably all haven't done this, but when you do get into a situation where you got to go through a little frame or a window to machine something, this can be very, very beneficial for controlling that. And this is something that I used to have to go to almost other software for, and now it's in Fusion 360 and I have the ability to do this. So this is a big, big help to me. The last thing that I have to show is just some of the undercut capabilities and like that 4th axis that I was showing. We could obviously do some rotary strategies in Fusion and trim them to certain areas, but we can even do that with steep and shallow. Now, the limitation with rotary here is rotary is for 4-axis only. So if I wanted to tip my tool at a certain degree, I wouldn't be able to necessarily do that. But steep and shallow, because of its multi-axis controls, it allows me to do something like that. So I can machine that same area here with the tool tilted. I can go all the way around the part if I want to like this, and then I can even tip it if I want to. So we can get some really good results here, and this brings a ton of control to Fusion 360 so that I don't have to go out and get other software or get specialty software just to do this. Fusion 360 can really grow with you and your capabilities. So with all that being said, let's hop back to my PowerPoint because we're nearing the top of the hour, and I'm going to go to the summary. So in this webinar, here's some of the things that we covered. We talked about how the machining extension can bring added value to your business by probing and inspection process automation, by hole recognition automation, by toolpath editing for faster and efficient toolpath results. I think we all saw that. And then the 4-axis rotary toolpath options, the 5-axis controls to speed up programming with like tilt and turn and some of the options that I just showed you. And then last but not least, steep and shallow, which to be honest is the best 3D finishing strategy because it encompasses all those things. With all that being said, we have a few minutes left for questions, so let's take some of those questions.
Thanks so much, Devin. Here's our first question, and this was asked during your tilt and turn example. Is this for multi-axis only?
Yeah, so specifically, depending on what solution you choose, obviously it could be for multi-axis, but if you use that tilt and turn like on a rotary and you want to spin to a certain angle, as long as the output can be handled by your machine, it would certainly be able to be done. So I guess the answer is it's not only for multi-axis, it could be used for other things.
Awesome, thank you. In terms of manufacturing strategy for complex parts with multi-holes and multi-surface configuration, what's the best type of machine to use, 3 or 5 axes, to achieve the best speed and best quality?
I mean, if you take something simple like a dice, right, you could machine that in 6 different operations in a vertical machine. Now, the problem with doing that is every time we take it in and out of the machine and somebody has to handle that component, we might lose some accuracy. Maybe I put it and clamp it in the machine, don't have it all the way tight up against the stop. So with multiple loading and unloading and multiple operations that are usually done by a person, there is that room for human error. So you're not going to make as quality of parts because you do have all those different factors playing in it. If I was to take that same component, put it in a 5-axis and do it in 2 operations or even 1 operation, I would have the ultimate tolerance there because no one handled it. And the machine made it in 1 go. So I would say it's better for 5-axis. Like in my specific case, we had 3-axis machines, we had 5-axis machines. I got really lazy and I really only wanted to do things in the 5-axis machines because it was so efficient. And those were the only machines in our shop that were really backed up the entire time because we wanted to put everything on them, even if it's not a fancy impeller, even something like a dice could go on a 5-axis. You could do 5 sides, flip it over, do the last side, and you're done. Or you have to do 6 different operations and movements in a regular vertical. So I hope that answers that question.
Awesome, thank you. Is it possible to do some corrections on the parts in Fusion 360, like geometry, dimensions, tolerances, while the process of machining is already going on?
Yes, I mean that is a major benefit to Fusion. I don't know how many examples I have, but even if you move or adjust something, because everything in Fusion is parametric, it's going to update the toolpaths. So even like on our probing, let's look at a specific operation here, like even this finish island or the inspect. There's a bunch of different operations going on. If I go back into design, and even very crudely, this was made in Fusion, so I do have all the history of the timeline in here, but even on an imported part, I can still modify and move this. So I could just window select something like this. I could right click and say move copy. I could move and adjust this feature and hit OK. And now when I go back into my manufacturer, because everything's associative, this finish island, you see where that toolpath lands? If I right click on this and hit generate, you can see that it's going to update to that new component there. So we can modify, adjust faces, do all those things in manufacturing. In design and then carry those into manufacturing. If you have more specific questions, certainly reach out to us. We'd love to, talk to you a little bit more about your specific need.
Great, thank you. Does Fusion 360 include a metrology tool that automatically calculates and set the best possible tolerances for parts machining?
Yeah, so as far as MBD, which is model-based definition, and PMI, which is product manufacturing information, we don't utilize any of that today in Fusion. That is something we're looking into. And then as far as the metrology side of it, there are some things you can do to obviously measure the component and then make adjustments. But as far as correct machining strategies or things like that, there's nothing that I believe exists out there today.
Okay, thank you. That's all the time we have for now. Thanks so much, Devin, for the great demos, and thank you, attendees, for joining us. We hope to see you again for future webinars. Bye for now.
Thanks so much, everybody.